All right, everybody. Today we're going to go over exercise 16 takeoff. Right around here in your flight training, you should be beginning to do some takeoffs during each lesson with assistance from the instructor. So we'll go through our takeoff presentation before we continue with any more air work. What we're going to cover here, we're going to go over takeoff performance calculations, briefings, the takeoff procedure, different factors affecting our takeoff, and then some of the emergencies associated with this critical phase of flight. The reference is the flight training manual. But the goal is just to learn how to safely get the airplane airborne under different conditions such as crosswind or shorter runway length. Obviously, this is required for every single flight. We got to be able to safely take off. And to be able to do it safely under challenging conditions. It's going to build on attitudes and movements and your climbs, which we've already learned. Any questions, just leave them down in the comments below and I can answer those for you. All right, some background knowledge prior to beginning our lesson here. Starting with number 1, describing the outside picture in a nose-up attitude. We're going to see less ground, more sky, and the nose is going to be above the cruise attitude. The procedure used in a climb is always attitude, power, trim. The maximum angle of bank in a climbing turn is 15 degrees, and this is to reduce the risk for the airplane to overbank and stall. You're also going to have a reduced climb performance the more you bank. So it doesn't make sense to be in a 30-degree angle of bank while you're climbing because you're just going to end up level. Number 4, how do we fly a straight track? If there's wind, we're going to have to do a wind correction angle. So this is called crabbing into the wind. The causes of unwanted yaw that we've covered so far include slipstream, propeller factor. There's also aileron drag or adverse yaw, as well as gyroscopic precession and torque. But there's the 3 we've covered so far. Alrighty, as for today, the definition, the takeoff, this is the distance from your brake release point to where the aircraft reaches a height of 35 feet over the surface. That's considered your takeoff. The takeoff distance is the distance required starting from stationary, accelerating and climbing to 50 feet. The ground roll is the distance required from your stationary point, accelerate until the landing gear is off the ground. So right out of our POH, here's the POH for a 172. We're looking at the short field takeoff distance at 2,400 pounds. It's important to note the weight and make sure you're using the proper chart. And also read through the conditions of the takeoff. So these conditions, we have flap 10, full throttle prior to brake release. It's a level paved dry runway with no wind. And it gives a liftoff speed and a speed at 50 feet. This is basically your short field technique. So not all those conditions are going to apply with a normal takeoff for the 172. But if we're just looking at the chart itself, we want to figure out our pressure altitude and the temperature. You can find these from a METAR, the altimeter setting, and the outside air temperature. So here we'll say it's 20 degrees and we are 2,000 foot pressure altitude. So you're going to come to this column in row. So actually this is we're on the 1,000 foot column there. So we have a ground roll of 940 and the 50 foot obstacle of 1605. Now, we would have to read the notes and apply some factors to these figures. So note number 1, the short field technique used, specified in section 4. So these distances are only going to be valid if you're using that specific technique. If you're doing a normal takeoff, they're going to be a little bit longer than this. Number 2, prior to takeoff from fields above 3,000 feet elevation. The mixture should be lean to give maximum RPM in a full throttle static run-up. Alrighty, so we'll keep that in mind for our takeoff. Number 3 is an important one. Decrease distances 10% for each 9 knots headwind. For operations with tailwinds, up to 10 knots, increase distances by 10% for each 2 knots. So that says a maximum tailwind of 10 knots, and we're going to increase it 10% for each 2 knots. We'll never take off with a tailwind. You'll always take off into wind with a headwind. And if it's a 9-knot headwind, your ground roll and your 50-foot distance are going to be reduced by 10% each. And we can do the math to calculate if we only had a 5-knot headwind or if we had a 10-knot headwind, how that's going to affect the numbers. The last one, operations on dry grass runway, you're going to increase distances by 15% of the ground roll figure. So both distances would be increased by 15% of 940. Alrighty, let's get into the takeoff briefing. This is always done before our first takeoff, and it's just to help mentally prepare you and to catch any mistakes that you could have made going through the checklist for the takeoff. So we want to include the runway you're taking off from, the wind condition, your type of takeoff, your airplane configuration as far as your flap setting, a go no-go point, rotation, climb out speed, and then we'll finish it with the emergencies. So a go no-go point, this is your calculated location where the airplane's expected to be airborne. Essentially, it's your ground roll figure or 2/3 of your 50-foot takeoff distance is going to give you a good calculated go no-go point. If you're at this point and you're still on the ground, you would reject the takeoff. Now, why would we reject? Is because something could be wrong, but you don't know what is wrong. Possibly the engine's not developing your rated takeoff power. The density altitude is too high, so your airplane's not getting very good performance. Maybe you made an error in the calculation, and that's why you rejected. So lots of different reasons why, but it's important if it is a real emergency, you're safer to stay on the ground opposed to forcing the airplane into the air. The wind condition, best option is just to look at the windsock and know, okay, 30 degrees below the horizon is 6 knots, 5 degrees below the horizon is 10 knots, horizontal is 15 knots or greater. Each of the colors is approximately 3 knots there, so you can look at that and see how many stripes are horizontal, and they each represent approximately 3 knots. An example of the takeoff briefing here, we have taking off runway 27, the wind's a left crosswind, we're doing a normal takeoff with flap 0. The go no-go point is our 5th set of runway lights. We'll rotate at 55 knots, climb out at 74, and any emergency prior to rotation, you're going to reject and stop on the runway. An emergency after rotation with enough runway, we're going to land and stop back on the runway. And an emergency after rotation without sufficient runway, you're going to continue to fly the airplane and land in the most suitable site straight ahead. Here's our takeoff procedure out of the POH. A normal takeoff, flap 0 to 10 degrees. Full throttle. The mixture should be rich from your pre-takeoff checks. You're going to lift the nose wheel at 55 knots. You hold it, essentially doing a wheelie down the runway. Just wait for the airplane to lift off. And once the airplane lifts off, you're going to climb out at 70 to 80 knots. And then you would retract your flaps at a safe altitude. Okay, so lining up in the runway center line, we want to use maximum runway available. You can see in this diagram, we're lined up runway 26. And if you look at the far end of the runway, it's going to help you maintain center line. We don't want to stare directly on the ground in front of us. Now, the rotation can be commonly confused as the liftoff point, which would be incorrect. The rotation is the airspeed at which that you lift the nose wheel. So the main gear will still be on the runway, but your nose wheel will be in the air. You're still accelerating, and you just hold it in this attitude until the airplane lifts off, and it'll lift off whenever you're developing enough lift, and it happens all on its own. So important, the rotation, only your nose wheel lifts off the ground, not the entire aircraft. As you're climbing out, it's good pitch for your best rate of climb, and you're just going to maintain this and climb up to altitude. If there's any after takeoff checks, you can complete those once you're at a safe altitude. If you took off with flap 10, which would be non-standard in a 172 normal takeoff, it would be at a safe height, so above all obstacles, before you would lift those flaps. Alrighty, so now we'll talk about some crosswind inputs. They are the exact same as taxiing, so if the wind is straight or forward, you're going to hold it steady. If the wind is from your right or a right headwind, just turn your controls into the right. If it's left, you just turn your controls to the left. And if we have a quartering tailwind, so if it's from our back right, we're going to dive away, so our control yoke goes in and we turn it to the left. And if we have a quartering left tailwind, we'll go forward and right. This would be during the roll as we're accelerating to VR or as we're taxiing. So we can calculate the crosswind using this chart here. Basically, we'll take our degrees off the runway. If we're 30 degrees off the runway, we'll follow this line down to your wind speed if it's 15 knots. And then from here, we can go straight down to see that it's roughly a 7 or 8 knot crosswind, and straight over to see that it's a 13 knot headwind. So that 13 knot headwind would have to be applied to our takeoff performance chart. All right, now we're going to talk about some of the factors affecting your takeoff performance, what's going to increase it and decrease it, and we'll go through each of these. So if we have additional weight, it's going to be reduced performance, so it's going to take longer to take off. A higher elevation is going to reduce your performance because a higher elevation is going to have less dense air. We have less lift. It's going to take longer to produce lift and take off. A higher pressure altitude or density altitude is going to be the exact same thing. The wind is going to depend. If it's a headwind, it's going to be increased performance. If it's a tailwind, it's going to be decreased performance. So this is why we always take off with a headwind. A higher temperature is going to be reduced performance because warmer air is less dense, less lift, longer takeoff. High relative humidity, exact same thing, is going to be less dense air, less lift. Flaps is going to depend. Flaps 10 degrees may be used in some specialty takeoffs, which we'll talk about, a short field takeoff or a soft field takeoff. But if we have too much flap, an example would be full flap, it's going to really reduce the performance of your takeoff. So we'll talk about the wind and how the aircraft is going to perform. All the way to the left here with a tailwind, you're going to have a really fast ground speed. It's going to cause you to take longer on the ground and a less steep climb if we're talking in units of time because our ground speed's much higher. So we're going to cover more horizontal distance quickly while climbing at the same rate. If we have a headwind, you're going to have a slower ground speed and a shorter takeoff distance. You're going to have much better obstacle clearance because we have that short ground speed or slow ground speed, and we're climbing at the same rate, but in turn, it's going to be a shorter horizontal distance to take off. Now flaps, If we have no flaps, it's going to be a longer ground run and a faster rate of climb. Compare if we do have flaps, it's going to be a shorter ground run and a slower rate of climb. So if we have flaps down, the airplane's going to lift off the ground shortest, but it's going to climb slower, shown here at the blue, on the blue dotted line. If we have no flaps, it's going to take longer for the ground run, but once you are airborne, it's going to climb a lot better just because we have less drag on the airplane, so it's going to be able to climb better than if we had our flaps down. And the transition when to use flaps, when not to use flaps, really depends on obstacles. So safety for today's lesson, we want a decision point or a go-no-go point. We want to maintain directional control during our takeoff roll. Keep in mind our crosswind limitations for the aircraft and any emergencies that could happen during the takeoff. It's a really critical phase of flight, especially right after rotation. One of these emergencies is the engine failure after takeoff. The most important thing is to continue to fly the plane. So do not stall the airplane. It's not going to end well for yourself. So if the engine fails and the nose is going to be in a nose up attitude, we're going to be losing airspeed rapidly. So immediately you got to pitch the nose down and aim for your best glide speed. You would level the wings if they were in a bank. If we're under 1,000 feet, you cannot even think about turning back towards the runway because you're not going to make it. You're going to continue straight ahead and land in the most suitable area. It could be a field, it could be a road, it could be trees. That's going to be a better solution than a stall in any of those scenarios. As soon as you're above 1,000 feet, you can consider turning around, landing back on the opposite runway. In this diagram there, it'd be 0-2. Keep in mind you're most likely going to have a tailwind. These should be demonstrated by your instructor and show you how close it really is for that 1,000-foot mark to make the field or not. Okay, some review questions here. So the procedure for a normal takeoff, you're going to line up, you're going to go full power, maintain directional control, accelerate, rotate at VR, climb out at VY. Your go, no-go point is going to be your point where you would reject the takeoff if you are not airborne. 3 factors affecting the takeoff. Well, we had weight, we had temperature, we had pressure altitude, density altitude, the wind, and flaps. What is included in the takeoff briefing? We got the wind, the runway, the type of takeoff, your flap configuration, go, no-go point, speeds, emergencies. So that's it for the takeoff here. Hopefully that'll help improve your takeoff. You can understand some of the theory behind it. And you should be practicing the takeoff every flight from here on out and just keep on improving. Any questions, please leave them below. And the next lesson we're going to go up and do is range and endurance. And then we're also going to talk about the landing after that one. Alrighty, that's it for today, guys. Thanks for listening, and I hope this helped.